some concepts we have discussed. No?
Okay. So
Knowledge
we just
base, knowledge
started with,
repository.
okay, knowledge base,
What
neural
is
net.
knowledge base? What is
I think,
repository? Knowledge repository.
okay. So did we start about neural network? Not yet, right?
Not yet.
Not yet. Okay.
The main we are. You said that we are planned to read something neural network, psychology of neural thing.
Right. Okay. Okay.
That's what you start up. Okay, then we will discuss in the next class that you have said.
Right.
Yeah, we started with artificial neural networks.
Oh, okay. Great. Okay. So from the code itself, we can just we can go and
We
start.
finished Thomson sampling and
Ah,
reinforcement learning.
okay.
And then we just started with artificial neural networks, but we did not continue in that.
Continue. Right. Okay. So this is the code for ANN. I think you are seeing right. Okay. So here, I mean, this is the code as of now. You know, I don't want you to run anything because it will take some time to understand what is inside in each and every um, aspect of the code, and then first we will break down what are all the new informations because we just touched upon the neural network. The first is artificial neural network, and then what we do. This is my way of teaching, starting from deep learning. Okay, so we need to break down each and every new terminology first. Okay, because here the new terminology is TensorFlow. So what is this? And we have to capture this. And then if you see, I think the label encoder we have seen in basic machine learning itself. But we'll see, the label encoder, how it just encode or transform from one. It's just kind of a transpose. Okay, the prop transpose in SAS, a similar kind of a transformation it will be doing. That is
one got encoder we seen, label encoder
yes.
we didn't know.
Yeah, the same kind of a concept.
Same thing. Oh, okay.
Yeah, same. See, here you can see, right, one hot encoder. Yeah, here pre-processing we are doing one hot encoder. Again, from compose package from sklearn, there is a column transformer. That is, we are just adjusting or changing column to row into column. That is one. Yeah, one hot encoder, the same kind of a procedure it will be doing. And then the train test model, the split that is happening, and then the feature scaling. And then the next phase is we are initializing artificial neural network, especially in TensorFlow Keras model. So there are two terms right now. So TensorFlow, we need to explore. What is Keras? We need to explore two things. And then it's very important in neural network. It is called as hidden layers. First is input layer and then hidden layer and then output layer. So we'll see one by one. In that hidden layer, there is a function called activation function. Okay, so in that activation function, there are so many activation functions that are there. It will impact the output of any neural network. What kind of an output and how it just getting impacted. So we'll be seeing one by one. Okay, and then we are compiling ANN processor and processing, and then while doing the compilation, again we have to apply the optimization technique. So in machine learning, there are so many optimization technique we have seen. Here also, we have to optimize it for each and every neural network algorithm. You have to do the optimization technique. If you are not doing any optimization, then it will be at loss, kind of a loss function, right? That means you won't get the accuracy, the expected accuracy that is also there. Okay, and then again we are trying to fit the ANN with the number of iterations. Here you can see the epochs. So epoch is nothing but, I mean, EPOCH is nothing but it is an iteration. I'm just giving 120 iteration, for instance, for this particular neural network to find out the right accuracy. So you can see the loss function and the accuracy, rate of accuracy. So you can see, even you can change this epochs. Maybe you can reduce it, you can increase it based on the accuracy level, just to see the accuracy, number of accuracy. But if it is getting uniform accuracy, then we can stop in this epoch, I mean in this iteration itself. So there should be a reason why they have given 120, why they will be giving 80, 60, whatever the reason. And again, this number, it is based on experience of a programmer. And again, you can take a call which number you want. Okay. So this is the maximum accuracy. These people are, I mean, from this model, they are taking it. Okay. So now I don't want you to look around each and, I mean, the entire thing, and I don't want you to run the code as of now. First, you will see the TensorFlow. Okay. So, and then I would, we will explain what is TensorFlow first, and then we'll go one by one. Right. TensorFlow. .org. So from here onwards, no, you are not a basic machine learning developer or programmer. You are a deep learning developer or deep learning engineer. Okay. So TensorFlow, what is meant by TensorFlow, right? So this is the official website of TensorFlow, tensorflow.org. Okay. You can just note it down, or I will send this link in your chat. So this, you can just take it. Okay. So first of all, we will what is TensorFlow and explain with simple examples as on a beginner level machine learning. This is one of the prompts that it will be used to get a more explanation about TensorFlow. Okay, right. Right. So to be precise, it is an open source framework developed by Google. Okay. So it is an open source framework developed by Google for building and training machine learning models. It allows you to create complex neural networks using simple building blocks. So TensorFlow is popular because it provides flexibility and scalability, making it suitable for both beginners and experts. This is a very simple explanation about TensorFlow. Okay, so it is an open source framework from Google. Okay, and just imagine without TensorFlow framework, we will not even be able to visualize the Android worlds. Okay, forget about the deep neural network. Anyway, we'll be using this libraries, open source libraries for lot of applications, especially if you are developing a mobile application. TensorFlow makes it more user friendly because they made it as a open source, so that you can you'll be able to use Android application. Just imagine if they don't make it as an open source. We might not get this kind of an application, the entire. I think because um, Android and iOS, these two platforms hold the maximum mobile application market, mobile application uh, developers and other stuff. So they are, I think, in that two operating systems, Android OS and iOS. So these two operating system in the mobile technology, it's kind of a revolution, right? So without these two things, we never imagine this kind of things, would be possible, right? So now we are just we are doing a lot of things at very, very comfort level, luxury level. Without TensorFlow, there will not be possible for doing a lot of product applications. That is why they made it open source. Again, there is a business concept behind it. Anyway, without Android, we cannot place or deploy this application. So there, if you wanted to deploy in Android, you are using open source package TensorFlow, right? They are giving it for free to make an application. They just charge for deploying the application. That's it. So it's a very, very cleverly, done the marketplace. And in one way, it is really useful. Just imagine if they are, asking you to pay more for TensorFlow, then they have to, because they are kind of a monopoly right now, right? So, but they didn't do. But for some of the applications, they'll be asking. And recently, thousands and thousands of applications has been removed from Android because of the applications will not be carried out, or they are not following the recent policies, and they didn't check the policies. It seems one of the main applications have been removed, that is called as matrimony. Even at that time, it was very, very um, talk of the day. It happened very recently. Okay, so because without TensorFlow, there is no application, because a lot of machine learning applications they are giving you as a application programming interface. Just look at this. Okay, TensorFlow JavaScript, TensorFlow Lite, and there is the other things as well. So these are all the things. If you are a developer, mobile developer, you can install it. And otherwise, we are accessing this TensorFlow, platform or framework through uh, as a library. So we are just importing TensorFlow like this. Okay, so otherwise it will just work, because it is from Google, and Google Colab. If you are working, then you can directly go and work because it is inbuilt. If you are going out of this IDE, Jupyter or Navigator, something else, then you have to install it. The PIP install TensorFlow. So each and every time you have to install this. Okay, so this is some kind of an insight about TensorFlow, because without this, it will be slightly confusing going forward. Why this library? What is this library? Why we are using? And what is the impact on it without using it? Even without TensorFlow, you will be able to run a model, right? That is also possible. Don't think that only TensorFlow is available for neural network. That is there, but in experience, most developers, they are very comfortable using TensorFlow. So we'll be seeing, one by one. Don't worry. Okay, so this is all about TensorFlow library. Okay, so you can just run. So within this TensorFlow, what is a Keras? Okay, explain about Keras. Okay, Keras is a high-level API for, I think API is nothing but application programming interface. So application programming interface in the sense, now I'm typing through ChatGPT. Okay, ChatGPT is an application, right? But how I'm getting this response from ChatGPT, this is where the API level of information. I already introduced during the Python class. There is a Spotify API. Okay, I think I have shown you. Okay. So if you wanted to develop some of the programs, I mean, some of the playlists directly, from Spotify, that is all doable. It's possible, and that is why they just make it free for developers. It is a different login credential, apart from regular Spotify. Okay, so this is especially for developers, right? So if you are accessing their API, what we have to do, you have to enter Spotify, SPOTI, pi. Pi is nothing but Python file. So that is, I mean, that means you are just interacting with their application programming interface, and then you are just using that interface, you are getting the response. Similar way, Keras is also a high-level API for building and training neural networks. So it acts as an interface for TensorFlow. Okay, so that's what I'm saying. So it acts as an interface. In between, there is a Keras layer to access the TensorFlow framework and makes it easier for beginners and advanced users to work with the deep learning models. So Keras abstracts the complexity of building neural networks by providing simple user-friendly functions and models. So if you are using TensorFlow framework, definitely you will be using Keras API in that model. So key features of Keras: user-friendly. Keras is designed with simplicity in mind, and it allows for rapid prototyping with minimal code. You can also create a simple prototype. So like what we are doing for ANN. It's a mere prototype model, very simple model. Okay, and
What is
modular.
ANN, Sini?
ANN, artificial neural network.
Oh, okay.
Artificial neural network. First, we'll just discuss the library, and then we'll go with the ANN concept. Right. So this is also a modular. Modular in the sense it provides modular for layers, optimizers, activation functions, and more, which you can easily plug into your models. So integration with TensorFlow. So Keras is fully integrated with TensorFlow, allowing you to use TensorFlow's powerful features while keeping the code simple. So you'll be able to integrate with TensorFlow easily. Support for multiple backends, right? So initially, Keras supported backends like TensorFlow, Piano, that is also kind of a TensorFlow model, and CNTK. These are all mobile application and mobile interfaces, but now it is tightly integrated with TensorFlow. So Keras, they just wanted to move only for TensorFlow. So what is the basic structure? So a typical neural network model using Keras consists of a define the model, right? You can specify the layers. So I'll be explaining what are layers in artificial neural network, right? Compile the model, configure the learning process using optimizers, loss functions, and metrics, train the model. So you are going to fit the model on the training data, evaluate the model, and you are going to make a prediction. So as of now, just understand TensorFlow is a broader framework. Keras is an API to interact. This is a high-level API to interact with the TensorFlow framework. Simple. Okay. Right. Okay. Now we are going to discuss about artificial neural network. Let's close it. Just see this simple layers. Okay. So this is an input layer, the orange colored or something maroon color, and then the hidden layer, the blue one, and the output layer is the green one. By seeing this information, what are things you are getting in your mind? By seeing this image, what are you thinking about the neural network? Any idea?
Different selections, like
Different selections.
from the input layer, if you see the output layer. So from out of three things, one is got selected based on different combinations,
Okay.
different input, different possibilities combinations. From there, they're picking the output.
Okay. So I do you have any thoughts?
Yeah, I think it is performing the permutations and combinations. Like, if you see each cell, or if you consider as an entity, each entity is interacting with every other entity in the hidden layer one. And then again in the two, it is again each four individual entities are interacting with every entity in the hidden layer two. Out of all this combination, one particular output is coming out, which is similar to everything.
Okay. So I will tell you this scenario. Okay. So right now, right now, we three in this conference call, and we three in this meeting, and we are discussing about neural network, especially artificial neural network. Though I am talking to you, though you are also listening to me, there are other thought process also just going on in our mind. That's how the mind is. Okay. If I'm talking to you, I'm just talking. Okay. Simultaneously I'm just trying to think. Can I show some other URL? Can I show some other beautiful images of this? Okay. So what the concept is, I can cover up in this. Even though I just selected this, my mind right now just thinking to perfection. I mean, make it more perfect for this. Algorithm. This is how. The similar way, you will also think that what you will be. I mean, what I'm going to teach. Is this what is this diagram? There are so many other thoughts will be just coming, but that is the input. Okay, that is the input layer. So there are so many inputs that you will be trying to give to the your brain structure. Just think, we take it our human being as of now, and then we will be discussing about the machines. So, as a normal human being, we are thinking about too many things at the same time, and it is going and processing. And yes, and as Sai said, with permutations and combinations. Most of the time, it is a mathematical calculations, even scientific calculations, and that are just interconnecting. The information is passing through this things, I mean, to the frequency, the other things. We are, again, we are giving some weightage. That is also there. We are giving some weightage in the hidden layers, right? What can be done? Because, say, for instance, we are thinking about three things at the same time, based on the priority, based on the weightage, based on the other things. Okay, this time I wanted to talk about ANN, that is output. Say for another scenario, case study. If you are thinking to go out, I mean, maybe you are starting, from your home to your office. If you are just starting to commute, there are many different ways are there to commute to your office, but regularly you will find some ways which is, which doesn't have, or which is minimal traffic, right? But at the same time, you are thinking whether we can just, reach out to some other route, or how, I mean, it's always happening. Okay, so it's a normal human being, every human being, we will be thinking that, like, today we've just taken this route, maybe, we would have taken, I think, 5 minutes, we will be reducing. Maybe if we would have taken some other route, there will be no traffic. Always, we, our mind will not be, stopping, or will not be, very, just very simple, and we never, because the thought process is always coming into your, for all the things for decision making. That is why we are getting confused a lot of time. That is why we are getting a lot of pressure at a lot of time. That is why we are getting pressurized a lot of time, right? Because of too many thought process to make a decisions, right? So in hidden layer, based on the regular route, maybe the regular, maybe it comes through your experience, and it comes through the weightage, right? And the information is getting passed, and then you are taking some. Finally, you are just making some output. So that is why you used to say, even in machine learning, right? In between, our life is a deep learning machine learning, our life is a deep learning, our life is AI, and vice versa. Okay. So each and every part of your thought process will be happening in the thing. So this is where, I was saying about, think about the psychology of human being. So in artificial neural network, okay, but if you start off with a convolutional neural network, that is an advanced of ANN, then there will be, too much of the human beings' effort and other decision making processes, and that is where, we are converting those processes into mathematical algorithm, and then we are slowly getting the output. So in ANN, just to see, convert this scenario. So if you are, the input might be, goat, input might be cat, or input might be dog, right? If you are just trying to give, what would be the output? So based on the training model, okay, so based on the training of this ANN, already you would have, done too much of a training of goat, too much of training for a cat, too much of training for dog. So based on those kind of calculations, this ANN should find out the real image of whatever you're giving as an input. It has to find out this is a dog. It has to find out this is a goat. This is, it has to find out this is a cat, and so on. Okay, so it's a kind of, the finding out the facial detection through the training processes. So what is actually, or what is really happening in between this hidden layers? Okay, that is what you are going to see, right? Okay, so what is an artificial neural network? So artificial neural networks are one of the main tools used in machine learning. As the neural part of their name suggests, they are brain-inspired systems that are intended to replicate the way that we humans learn. So neural networks consist of input and output layers, as well as a hidden layer consisting of units that transform the input into something that the output layer can use. So what is a hidden layer? A hidden layer is nothing but it consists of units that transform the input into something that the output layer can use. They are excellent tools for finding patterns that are far too complex or numerous for a human programmer to extract and teach the machine to recognize. So whatever I said right now, if you just give any image, it has to find out. If you give any kind of information, it has to find out this is what the information is. Okay. So when it is getting started. So while neural networks, also called as perceptrons, have been around since 1940s, it is only in the last several decades where they have become a major part of AI. Okay, so this is there. This concept is there since from 1940s. So this is due to the arrival of a technique called backpropagation. Okay, so which allows networks to adjust their hidden layers of neurons in situations where the outcome doesn't match what the creator is looking for. Okay, so I already told you one information. Um, if not, maybe because there are recently, I took the same kind of a topic for the other team for Sauram College too. Okay, so I think I told you this. Uh, the father of ANN, I told you, right? Father of, I'll show you. Chef, yes, this is okay. Actually, I met him in Canada. So this year he got a Nobel Prize. I will go to this Wikipedia. Right. This is better. Okay. I attended this guy's, conference in 2018, the same period, November, end of October, I guess, in 2017. And at that time, I was not aware that this guy is, father of AN. And it was very, I think 300 or 400 people, they all are youngsters, young entrepreneurs were there, and we just, he just introduced about the ANN, how he has created, mm, why he's the father of ANN. Actually, father of ANN, there are so many people, but the thing is, this is he's a godfather of ANN. He identified the back propagation methodology. What is back propagation? So actually, without this back propagation, without his invention, we never had to use ChatGPT in our life. I mean, that is a revolution in AI. It's a recent revolution, and from that revolution, every company just investing in this model, and we are seeing so much of the robotics, how we just transformed, and how it is, it's giving you the reply responses, and how so fast. And previously, it doesn't, because that is only the feed forward propagation. Okay, so we'll just see. ANN will take time, at least 5 days or 6 days or 1 week. Don't mind, okay, because that is how we have to read. And afterwards, we will, very not very fast, maybe comparatively will be this, because you are jumping into deep learning. It is quite different. I can't just show, okay, this is ANN implemented and this is a the CNN implemented. No, I don't want to do that. Okay. So whatever we are doing, we have to do the best of our knowledge. So we have to wait. And I don't want to run the code and get the output. Doesn't matter. It doesn't make any sense. Okay. Right. And what is back propagation? Propagation. explain the difference between propagation and feed forward. Just note of these words: feed forward propagation. This is very important in deep learning. So without this, you never have this. If this meeting just ends, please rejoin, because I think I need to renew that the other company's Zoom account. So I just came from the other sessions. Okay. So backpropagation is a key algorithm used to train neural networks. Okay, so key algorithm used to train neural networks. It is a method for updating the weights of the model by minimizing the error during training. So at this point in time, you guys know what we are doing in machine learning. So obviously, we are improving each and every model. That means every model's ultimate goal or aim is that to reduce the error and increase the accuracy. That's it. The same way, so to increase the model, or minimizing the error, especially in neural network, to reduce the error, backpropagation is one of the key techniques and key aspects. Without this, you won't be able to get the right or expected accuracy. So how this has been implemented and others. How does it work? So we'll see one by one. The main goal of backpropagation is to adjust the weights. If I say weights, see, I'm just going here and there. Don't worry. And this is how it should be going forward. Be ready and mentally prepared. I'm just going here and there. But at last, I'm just connecting. There is no proper documentation for deep learning methodology. We have to go here and there. I learned it in a hard way. So I'm just giving mm, the essence of how I learned. That is why you'll be able to learn easily. Otherwise, it will take lot of time. And because I spent months and months on these things, and I learned it. It's not a hard way because I like it and I liked it, and that's how I got it. Right? Okay. So how this? If I say weight, okay. So you are, let's say for instance, the three images. So you are giving as an input. So what these hidden layers will do, it just analyze an input image, what is going on. Okay. And then it has its own way of analyzing an image. If the first image I'm just giving a goat, okay, and it's just analyzing this. Okay? This is just keeping, and then the other image, goat, but in a different angle or different posture, whatever it is. Again, third image, again the same one, goat, but it's a very, very I couldn't identify